The figure below shows a circuit diagram. R1 equals 1460 ohms, R2 equals 570 ohms, and delta V equals 30 volts. So it's R1, R2, and delta V. A. Determine the current in milliamps. Determine the potential of wire A relative to the ground. And determine the voltage drop across the 1460 ohm resistor. Now the standard definition for current, since we're finding the current in milliamps, the standard definition is we would say that delta V is equal to the current times the resistance. So the current is equal to, so I is equal to delta V over R. We have multiple delta V's and we have multiple R's. So we have, for example, a voltage source here, a voltage source here, and a voltage source here. But if you'll notice, they're not all going in the same way. So this voltage is going in this direction. This one wants to go in that direction. And so if we add this one and this one, we have to subtract this one. Or if we add this one, we have to subtract this one and this one. So I'm going to add the first two. That means I have a 30. So I have 30 plus 20 minus 30 divided by R. Well, what is R? It's the equivalent resistor. So since they're all in a series, I can just add them all. The equivalent resistor would be, I got 1460 plus 570 plus 2000 plus 1000. When you plug all that in your calculator, you're going to get a number right around, I think, 0.003976 amps. But remember, once it's in milliamps, so times that by 10 to the third, and so you will get 3.976143141. Now, since we've done it in that direction, it tells us something else, because we come out with a positive number. It tells us that the current actually is traveling in this direction. So these two currents overcome this one current, so the whole total current is going in this direction. And next it wants to know the potential of wire A. And so in order to do that, we got to pick which way we're going to go. If we go this way, then we're going to do more math, because there's 1, 2, 3, 4 different voltage changes along the way, whereas this way is only 3 voltage changes. So going either direction should give us the same answer, because the potential from here to here, it's a state function, and which means that the only thing that matters is the initial and the final position, and everything, how you get from one place to the other doesn't matter. The value is going to be the same either way. So it's actually kind of easier to think of it from starting at the ground. So if we start at the ground and we're going this way, we're going against the current, and so you would increase in current from here to here. So you would do I times R2, which I we said was 0.0039. So we're going to have to actually take the amps, not the milliamps. So 0.003976 times R2, which is 570. That gives us a delta V across that resistor, a delta V of positive 2.266. Then we're going against the resistor, we're going across the battery, so we're going to lose a delta V of 30 volts. So we got to do minus 30 volts. And then we go across the next resistor, we gain energy again because we're going against the current. We do I times R1, so 0.003976 times 1460. That's a positive 5.8, so 5.8. When we add all of these together, we get the potential drop from here to here. So you should get a negative 21.9284. Now the reason I said it was easier to start from the ground and go up, because it actually shows you that point A is at a lower potential than down here at the ground. And if you start from the ground, you're going to you would subtract R1, you would add delta V, and you would subtract I times R2, and you would find a positive 21.9, and that just shows you that the ground is higher by 21.9 volts than point A is. But by starting at the ground and going backwards, you get your sign correct. So you want to put in a negative 21.9289. Then the last thing, it says determine the voltage drop across the 1460 ohm resistor, and we actually already calculated that. It was the 5.8, it's not like 5.805169. And so that's if the current goes from here to here, you lose a voltage of I times R, and so I times R is 5.805169. Hey, thanks for watching. Make sure you check out my blog. The link is down in the About section of this video. And on the blog, you'll find cool stuff like other videos for the same chapter. And you'll also find little download links where you can download calculators to basically just punch in your numbers and solve these exact problems. So you won't even have to watch the video if you don't want to. The last thing I want to say is if you leave comments on YouTube, of course I will get around to responding, but I'm much faster if you leave them at the bottom of my blog, right down there. Enjoy your day.